I'm going to explain all about instrumentation calibration and why it is so vital in industry. Let's start with an overview of what calibration is and why it is needed. I'll then discuss the calibration process and talk about calibration frequency. As we learnt in the transmitter lesson, instrumentation is measuring the real-life conditions of a plant's process. Let's take an electronic pressure transmitter that is measuring the pressure inside a vessel. The instrument is connected to the site's control system via a 4 to 20 mA current signal. The control system then gives a readout to our control room operator so we can monitor and know the exact state of the plant. But how does the control room operator know that the pressure he is seeing on his screen is the exact pressure that is in the vessel? What makes him trust that this instrumentation is accurate and reliable? In many process industries, the precision of process variables instrumentation is measuring is extremely important for quality of the product that is being created, the safety of people and equipment, and for the profitability of the business. Regular calibration of the instrumentation is what gives us this confidence. Calibration is the process of comparing plant instrumentation to a known quantity to check for the instrumentation's accuracy. Adjustments are then made if the accuracy of the equipment is out of its allowed tolerance. The known quantity instrumentation is checked against is usually in the form of test equipment that is regularly calibrated to a high degree of accuracy. Test equipment calibration is often carried out at dedicated calibration labs that will be accredited to certain standards depending on the country you're operating in. Here in the UK, UCAS is an accreditation body that will ensure a calibration lab is certifying its equipment to the appropriate standard. Let's look at how we would carry out a calibration using our vessel pressure transmitter as an example. We are going to assume the transmitter has already been removed and is in the workshop ready to be calibrated. Calibration is often performed in situ, but that's something we'll discuss in a follow-up video. We would first need to know the range of the instrument so that we know what test equipment to select and to calculate our test points. The range might be printed on data labels on the instrument, or we could look at the control system block we are connected to in order to find the range. We would then connect a calibrated, suitably ranged pressure pump or calibrator to our instrument via its process connection. We would also connect the transmitter electrically to a calibrator to test the 4 to 20 mA current signal that the transmitter gives out to different inputs. This is what the control system is converting to a reading for our process operator. We would then apply various test pressures along the range of the transmitter and record the values on a calibration certificate. In a 5-point calibration, we will often be testing 0, 25, 50, 75 and 100% of the range of our transmitter. We would work out if the transmitter is within the required accuracy for a specific piece of equipment. Something like 1% of range maximum error is usual for general purpose pressure transmitters. We would also check for zero, span and hysteresis errors. This is called the as found test. If the pressure transmitter is out of its calibration limits, we would adjust the range or zero either through local potentiometers or buttons on the transmitter, or more commonly on newer equipment, digitally via a field device communicator such as a heart. We would then repeat the test to ensure we have met our calibration standard. This is called the as left test. The information we have obtained about the accuracy of the transmitter will be used to create a calibration certificate, usually electronically. This will then likely be stored in the maintenance management system for future reference. The equipment is usually labelled as calibrated and dated and then returned to service. Before I discuss calibration frequency, I'd like to ask what other information you would like to know about calibration or other instrumentation topics down below in the comments now. Remember to subscribe and you'll be able to see the videos I create in response to your queries. So, what determines how often we calibrate an instrument? Duty. If a transmitter's accuracy is safety and quality critical, it might be calibrated monthly. If it is just giving supplementary information, it might be only calibrated every 2 years. Manufacturer guidance. It can also be dependent on the transmitter type, and the manufacturer will provide a recommended calibration period in its literature. Standards. If, as part of your manufacturing process, you are accredited to ISO or other standards, then equipment calibration frequency is highly controlled and it will determine the frequency. Failure. Transmitters may need to be replaced and new equipment should be calibrated before being put into service. Events. Sometimes process operators may suspect equipment to be out of calibration due to abnormal readings. Investigatory calibration may be required to restore confidence in the equipment. I'll be following up this video with a walkthrough example in calculating max error and filling in calibration certificate, as well as calibration error types. If you have enjoyed the video and found it helpful, then please like and subscribe.